Hello everyone, welcome to Adhere Creations YouTube channel. As you all know, we at Adhere Creations have pledged to do our part to help the doctors and medical workers fight against coronavirus. We are donating about 50 face shields for their safety against COVID-19 in Bangalore. As the doctors save more lives every day, we will continue contributing more and more from our end and do our part. Along with the protective devices, we are also working on a ventilator design that can be put into use if there is a shortage of ventilators to treat COVID 19 patients. What we are working on is to make a mechanical ventilator using parts of Creality Ender 3 3D printer. Before we proceed with the details, please remember that this project is a work in progress and is not yet tested. With your feedback and ideas, together we can bring this design into life. Don't forget to subscribe our YouTube channel and hit the bell icon to keep yourself updated on our projects. Basically, there are two types of ventilator systems, manual ventilator and mechanical ventilator. Manual ventilator requires someone to make them work by hand and help the patient breathe. A big value mask (BVM), sometimes known by a proprietary name Ambu bag, is a handheld device that is used for manual ventilation. The bag is squeezed and released by hand repeatedly in order to keep the patient breathing. The Ambu bags are commonly available in the hospitals and medical centers. These are used in emergency cases when mechanical ventilation is not available. A mechanical ventilator is an instrument that does this process automatically and is usually controlled by computers. These are the ones that you usually see at the hospitals and are available in few numbers only. The best way to develop a ventilator is to use a commonly available Ambu bag and convert it into mechanical ventilator. And how are we doing that? As our title says, using the parts of Creality Ender 3 3D printer. Not only the 3D printer, but the parts with which it is made are simple materials and easily available worldwide. The parts of the 3D printer that we have used are X-axis aluminum extrusion, top bar aluminum extrusion, extruder plate along with the wheels assembly, NEMA 17 stepper motor of X-axis, extruder belt, pulley at the end of X-axis, X-axis stepper motor plate. Along with these parts, we have designed a V-shaped structure to hold the Ambu bag. This design is made in such a way that it is compatible with different size Ambu bags. It holds the bag firmly and prevents slipping away. We have also made a design for an end effector that will be used for compression and release of the Ambu bag. It is designed in such a way that a large surface area acts on Ambu bag, causing it to exert maximum force for its decompression. Using the parts of Ender 3 and the parts that we designed, We were able to come up with this mechanism to automate the manual ventilation process. The ventilator design consists of a vertical axis made from the x-axis of the Ender 3, a roller assembly, which is the plate with wheels on which the extruder is mounted, is used to move along the vertical axis. The top bar of the Ender 3 is used here as the horizontal axis, which is mounted on the extruder plate firmly. A NEMA 17 stepper motor, belt and pulley, which are parts of 3D printer x-axis, is being used to drive the roller assembly up and down the vertical axis. The working of the device is simple. The Ambu bag placed on the V-shaped structure. The horizontal bar on which the end effector is attached moves up and down, causing the Ambu bag to compress and decompress. The stepper motor can be controlled using an Arduino board and Raspberry Pi with a simple program for the motor movement. In a minute, the Ambu bag needs to be compressed and decompressed about 6 times for a normal breathing of the patient. This device can help in achieving it with its simple and fast movement of the motor controlled axis. Speeds up to 200 mm per second can be achieved on an Ender 3, and probably this device can be put to use for emergency situations where ventilators are required to save patients. The design is open source and available on all major platforms for you to share your feedback, ideas, and work on the design to improve it. With your help and contribution to this project, we can definitely achieve our goal of helping doctors save lives and fight against COVID-19. Thank you.